Hello everyone, in this video we're going to explore topic 6.10 enumerating functions using long division and completing the square. Alright, example number 1, using long division. Question A, find the antiderivative of 3x cubed plus 2x plus 5 divided by x squared plus 4. Alright, so we need to do long division, right? So we have 3x cubed plus 2x plus 5 divided by x squared plus 4. Right? Now 3x cubed divided by x squared, you get 3x, right? Now you're gonna multiply by 3x times x squared. It's gonna be 3x cubed, right? 3x times 4 is gonna be 12x, right? Then you're gonna do subtraction. So this guy subtract this guy, it could be 0. 2s subtract 12s, it could be negative 10s, right? You're gonna print 5 down. Now observe that the highest degree terms of this one is negative 10s. The highest degree terms of this guy is s squared. This guy has the degrees less than this guy, and then you need to stop, right? So you need to rewrite this one as the antiderivative of the quotient is 3s, right? Plus the remainder is negative 10s plus 5. You just put negative 10s plus 5, right? Over the divisor. Divisor is s squared plus 4. Alright, ds. Alright, now I need to separate this interim, right? So this guy turns out to be the antiderivative of 3s ds, right? And then negative 10s over s squared plus 4 antiderivative of this one ds plus antiderivative of 5 over s squared plus 4 ds. Alright, now antiderivative of 3s is going to be 3 times s squared over 2, right? Because you're going to use the power rule, right? Now for this one right here, observe that you have antiderivative of u prime over u du. It's going to be natural log of absolute value of denominator plus c, right? This one you learned from last lesson, right? So observe that if I take derivative of denominator, does that mean I have 2s, right? So I need to rewrite the top in terms of 2s, right? So right here I have 10s, right? I just write 2 right here, and then I put 5 in the front, right? So I can apply the formula right here, right? The top is u prime, the bottom is u, right? So this guy turns out to be, don't forget, negative 5, natural log of absolute value of s squared plus 4, right? Now last time you learned the antiderivative of 1 over u squared plus a squared du. It's going to be 1 over a tangent of u over a plus c, right? The formula is right here, right? So this guy turns out to be, now 5 I can bring to the front, right? So this guy becomes 1. So I can apply the formula easily, right? So this guy turns out to be plus 5 times, right? U, which means s, right? A, which means 2, right? Because a squared equals 4, then a equal 2, right? So formula 1 over a, which means 1 over 2 tangent of s over 2, and finally you need to add c, right? Now this one right here I can write 3 over 2, right? And this one I can write 5 over 2, right? And this one is the final answer. Alright, let's move on to question B. I'm going to do exactly the same thing, right? I need to perform long division, right? So I have s cubed plus 3s squared plus 8s plus 19 divided by s squared plus 5, right? Now I'm going to take the leading term right here, divide by leading term right here. Doesn't mean I get s. Now I need to multiply back. So I have s cubed plus 5s, right? So 5s should be right here. Now I have 19 right here. I need to put 0s squared, right? You need to line them up. Do subtraction, right? So this is going to be 0. This is going to be 3s squared. 8 subtract 5, it will be 3s, right? Now I need to bring 19 down. So plus 19, right? The leading terms is right here, divided by leading terms right here. 3 divided by 1 is going to be 3, so plus 3. S squared divided by s squared is going to be 1, right? Now you need to multiply back. 3 times s squared is going to be 3s squared. 3 times 5 is going to be 15, so I put 15 right here, right? So I need to have 0s right here, right? And then I need to do subtraction, so it could be 0, this could be 3s, this could be 4, right? And observe that this guy has the degree less than this guy, then you need to stop, right? So this guy turns out to be antiderivative of the quotient right here, s plus 3 plus the remainder is 3s plus 4 and divide by the divisor, s squared plus 5, right? ds. Right, now I need to separate this one, so this guy turns out to be antiderivative of s plus 3 ds, right? Plus antiderivative of 3s over s squared plus 5 ds plus antiderivative of 4 over s squared plus 5 ds, right? So antiderivative of s is going to be s squared over 2. Antiderivative of 3 is going to be plus 3s, right? Now for this guy right here, you're going to take derivative of the bottom. You will see it 2s, right? Now the top I have 3 right here, right? So I need to put 3 in the front. Then I'm going to multiply this guy by 2. And then I need to divide by 2. So that everything remains unchanged, right? So this guy turns out to be 3.5 is a constant. Rewrite this one. Now this one is u prime. This one actually u, right? So I'm going to apply the formula right here. It's going to be natural log of absolute value of s squared plus 5, right? And this one right here, I'm going to apply the formula right here, right? Where u squared equals s squared, then u equals s, right? A squared equals 5, then a equals square root of 5, right? So this guy turns out to be 1 over 8, which means plus 1 over square root of 5. Attention, of u over a, which means s over square root of 5 and then plus c. And don't forget to multiply by 4 right here, right? So you have 4 times 1 equals 4, right? Now observe that s squared plus 5 always positive. You may remove absolute value sign, so you can put the parentheses right here, right? This one is the final answer. Now let's move on to the next one. Iteration using completing the square. Alright, so if I have s squared plus bs plus c, how do I do complete square? Remember, you have a squared plus 2ab plus b squared this one can be written as a plus b all together square, right? Or if you have a square minus 2ab plus b square, it's going to be a minus b all together square. So keep that in mind, right? So if you given s square plus bs plus c, how do you do complete square, right? So you just rewrite the first term, rewrite the second term, right? Now the third term is you're gonna take the coefficient of the middle term, which is b right here. You divide by 2 and then you square, right? This one is the third term. Now you just literally add b over 2 square. You need to subtract b over 2 square so that everything remains unchanged, right? Now the c right here, I just rewrite it, right? Now I combine the first 3 terms right here. This guy actually a complete square right here, right? S square, I just write as b over 2 square, I just write b over 2, and then I'm gonna put the parentheses outside and then I square the whole thing, right? Now this one right here, I just rewrite it. I can simplify this one, right? Rewrite it like when it's come to a number, you can simplify, right? Now let's take a look at example number 2, iteration that requires completing the square, right? So this guy turns out to be antiderivative of ds over. Now rewrite the first term, rewrite the second terms, right? And the third term I put right here 7, right? Alright, now I need to add and subtract the same amount. In order to do that, I need to take the middle term right here, 4. Don't worry about the negative side, okay? 4 divided by 2 all together square. What is that? Does that mean 2 square, right? So I need to add 2 square. And then when you add 2 square, you need to subtract 2 square. Keep in mind the third term right here should be positive, right? You need to put the plus side right here. You're not going to put the negative side right here. Be careful, okay? Alright, remember, look at this one. The third term always positive, right? So this guy turns out to be the antiderivative of ds over. Now the first 3 terms right here, this one is actually a complete square. So it can be as the side of the middle term right here determine the side of the problem right here, right? Look, if you have the plus side of the middle term, this guy should be the plus side. If you have the negative side of the middle term, this guy should be negative, right? So this guy should be negative 2, right? All together square. Now I need to simplify this one because this one is a number different from this one, right? So you have negative 2 square. Remember, negative 2 square is going to be negative 4. But if you have negative 2 all together square like this, it's going to be 4. Be careful, okay? So this one equal negative 4 plus 7 is going to be 3. So plus 3, right? Now I'm going to apply the formula right here. Alright, so I'm going to let u be s minus 2, right? Then I have du equals ds, right? Now a square equals 3. Then a equals square root of 3, right? So this guy becomes the antiderivative of ds, which means du. So I rewrite this one as du, right? And s minus 2, which means u, right? So I have u square plus a square equals 3, right? So a equals square root of 3, so I cannot write square root of 3 all together square. So I can apply the formula easily, right? So this guy turns out to be 1 over a, which means 1 over root 3, tangent of u over square root of 3 plus c, right? Now, but u equals s minus 2, right? You need to plug that one back in, right? So 1 over root 3 tangent of s minus 2 over root 3 plus c, right? This one is the final answer. Now let's take a look at example number 3. Completing the square, negative leading coefficient. Alright, so this one can be written as antiderivative of 1 over. Now you need to rearrange this one, so this guy turns out to be negative s squared plus 3s, right? This could be like this. Alright, now you know that the first term of completing the square always positive. Look, this one always positive, this one always positive, right? But this one is negative. You need to factor negative one side out, right? So this guy turns out to be antiderivative of ds on the top, right? Square root of negative, right? Factor negative one out, so it could be s squared minus 3s, right? Then I need to add and subtract the same amount. Alright, so how do I fill in the blank right here? I need to take the middle term right here, which means 3 divided by 2 and then u square, right? So this guy turns out to be 3 over 2 all together square. Now you just add 3 over 2 square, you need to subtract 3 over 2 all together square, right? Keep that in mind. So this guy turns out to be antiderivative of ds over square root of negative. Now the first three terms right here becomes a complete square, right? So it could be, don't forget parentheses, s minus 3.5 all together square, right? Now you need to distribute negative 1 right here. So this guy becomes 9 over 4, right? So plus 9 over 4. Then this guy becomes antiderivative of ds over, now I need to rewrite this one as square root of 9 over 4 minus s minus 3 over 2 all together square. Now I need to apply the formula right here. Alright, so I'm gonna let u be s minus 3 over 2. Then du equals ds, right? Now a square equals 9 over 4. Then a equals square root of 9 over 4 equals 3 over 2, right? So this guy becomes the antiderivative of du, right? ds equals du over square root of 3 over 2 all together square, right? Minus u square, right? So then I can apply the formula right here. A square minus u square equal sine of u over a plus c, right? So this guy turns out to be sine of u over a, but u is equal this one right here. So it can be s minus 3 over 2 over a, which means 3 over 2 plus c. Now I need to simplify this one, so it can be sine of, now I need to flip 3 over 2, it turns out to be 2 over 3, right? So 2 multiplied by s, it could be 2s. 2 multiplied by negative 3 over 2, it could be negative 3 over 3, right? Plus c. This one is the final answer. Now let's move on to the next one, integration by adding 0 to the numerator. Alright. Now example number 4, adding and subtracting e to the s. Alright, so when you add e to the s and you subtract e to the s, does that mean you add 0, right? So this guy turns out to be antiderivative of 1 plus e to the s minus e to the s over e to the s plus 1 ds, right? Now I need to separate this guy, so it could be antiderivative of the top right here, e to the s plus 1, right? Over e to the s plus 1 ds minus the second one, e to the s, antiderivative of e to the s over e to the s plus 1 ds, right? Now I need to simplify, so this guy turns out to be antiderivative of ds, right? Minus antiderivative of e to the s over e to the s plus 1 ds, right? Now this guy turns out to be s, right? This guy turns out to be natural log of absolute value of e to the s plus 1 plus c, right? Why? Because if you take derivative of the denominator right here, right? Does that mean you have e to the s, right? Which is the top right here. So the top becomes u prime, the bottom becomes u, right? So by the formula antiderivative of u prime over u du is going to be natural log of absolute value of u plus c, right? Now, since e to the s plus 1 always positive, I can remove the absolute value side. So this guy turns out to be s minus natural log of e to the s plus 1 plus c. This one is the final answer. Now, let's move on to the next one, adding and subtracting a constant. Now, observe that if you take the derivative of the denominator, does that mean you get 2s minus 2, right? So in order to apply the formula right here, I need to rewrite the top in terms of 2s minus 2, right? So does that mean I need to add and subtract 1, right? Because I already have negative 1, right? So this guy becomes antiderivative of 2s minus 1 over s squared minus 2s plus 3 ds right here, right? So I can subtract 1 and then add 1, right? Look, everything remains unchanged, right? So now negative 1 minus 1 is going to be negative 2, right? So I can rewrite this one as minus 2, right? So it's going to be right here. So I can separate this one into two integral, right? So the first one is going to be antiderivative of 2s minus 2 over s squared minus 2s plus 3 ds, right? Plus the antiderivative of 1 over s squared minus 2s plus 3 ds, right? Now, the first one right here, I can apply the formula right here directly, right? So it's going to be natural log of absolute value of s squared minus 2s plus 3, right? And this one right here becomes antiderivative of ds over. Now, I have s squared minus 2s, I just rewrite it. Alright, I need to add and subtract the same amounts right here, so that I'm going to do complete square, right? Subtract, and I need to rewrite plus 3 right here. Alright, now to find the missing term right here, I need to take the middle term right here, which is 2 divided by 2 and square. 2 divided by 2 square is going to be 1, right? So I have 1 square right here and 1 square, right? Now this guy becomes natural log of absolute value of s squared minus 2s plus 3 plus, now the first three terms right here becomes a complete square, right? So this guy turns out to be antiderivative of ds over s minus 1 altogether square. Now I need to simplify this one, it's going to be 2, right? Now to calculate this one, I need to let u be s minus 1, then du equals ds, right? And I have a squared equals 2, then a equals square root of 2, right? So I can apply the formula right here, right? So this guy turns out to be natural log of absolute value of s squared minus 2s plus 3 plus ds equal du, right? So it can be antiderivative of du over u squared plus square root of 2 altogether square, right? And then this guy becomes natural log of absolute value of s squared minus 2s plus 3 plus 1 over 8, which means 1 over square root of 2 tangent of u over 8, but u equal s minus 1, so it could be s minus 1 over square root of 2 plus C. This one is the final answer. And it's your time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.